Hello everyone, welcome to this tutorial of week 10 practice question number 7. Mm, so this question is about serializability and locking. We will see about conflict serializability concept, which is ensured by the two-phase locking principle, and then we will review some concepts and also we will solve simultaneously. So let's dive into the question. What it is asking is is uh, schedule S is as given. Consider the statements, and we have been given three statements, and I have drawn the schedule with three transactions T1, T2, and T3 with the corresponding writes to be done. Okay, so all conflict serializable schedules are two-phase lockable is the first statement. The given schedule S is conflict serializable. The given schedule is two-phase lockable. So we need to validate whether these statements are true or not. So let us start from conflict serializability. That is something we have discussed earlier also. So it would be easier for us to do that. So let's start with conflict serializability at first. So let us try to see the conflicting instructions that we have, and then we will draw the precedence graph. And once we have drawn the precedence graph, then we will be able to find out the serial order which is there, right? So let us see the conflict. So see, T2 to T1 is a conflict for write on P. Also T2 to T3 is also a conflict because of writing on P. And then again T2 to this is Q. So yeah, so T2 to T1, there is a conflict, but T2 to T1 has already been discussed as a part of our conflict. So no new information over here, and there are no other conflicts, right? No. So these are the possible pairs of conflicting instructions that are there. And therefore, if I try to draw the precedence graph over here, so T2, T1, T3, right? So T2 to T1, T2 to T3, and okay, one more conflict I missed. I didn't see that, and which is T1 to T3 is also a conflict, right? T1 to T3, it is on WP, so that is also a conflict. So this is our precedence graph. Now, as we know, the precedence graph serial order, the longest path traversal in the precedence graph DAG will give us the serial order, serial schedule. So we can see here T2, T3, if I go, then I cannot come back to T1. So if I go from T2 to T1 followed by T3, then I have a serial order. So the given schedule S, right, this S schedule is conflict serializable to the serial schedule T2, T1, T3. So let us write it. Uh, the given schedule S is conflict serializable. This statement is true. Okay, and what is the, this is true. And what is the schedule that we are talking about? The schedule is 2 followed by 1 followed by 3, right? Okay, so now let's check the other two statements, and it is asking that given schedule is two-phase lockable. So now before moving into the concepts of two-phase locking, let us briefly revise a few things about locking protocols. So by the way, what is two-phase locking? Two-phase locking is where it is a mechanism or it is a protocol to follow while locking transactions operations, so that if we follow those protocol, we will get a conflict serializable schedule. So two-phase locking uh, ensures that you will get a conflict serializable schedule if you have locked according to the rules. What are the rules of two-phase locking? It's basically one simple concept which is stating that once you have started uh, locking data items, right, then you cannot start unlocking and then again restart locking, right? So let me restate it in this manner, that once you have started unlocking data items, at first in order to write something or read something, you will gain exclusive lock or shared lock. So basically you are lock gaining phase where you will gain the locks, and then at some point then you have to go and release the lock. So when you start releasing the lock, two-phase locking prohibits you to again restart gaining lock on other data item once you have started unlocking even one data item, right? So once you have started an unlock operation on any data item within a transaction, you cannot restart putting a lock on maybe another data item too, right? So once the locks are achieved and then you have started unlocking, then you again cannot restart locking on the same on or on other data item, right? So basically two-phase locking separates the locking, separates the transaction into two phases, and that's why it is called two-phase. The first phase will be lock gaining phase, and the second phase will be once you have started unlocking, the lock releasing phase start, and once the releasing phase start, you cannot again go and ask for another lock on any other or on the same data item. That's the whole idea of two-phase locking. So it guarantees conflict serializable schedule. Now, by the way, if you want to think about it intuitively, how does it guarantee conflict serializability according to this protocol? So if I have two transactions, let's say T1 and T2, and I say that, okay, I will allow you to put locks. There are some instructions over here. So I will allow you to put locks, let's say on the instructions which are written over here, and then let's say at this point I am doing the first unlock. The first, let's say, unlock operation is there. Okay, now once you have started unlocking, then I will do the unlock phase. I can only do unlock, I cannot ask for a new lock in this part. So if I am breaking it into these two phases, right, accordingly, let's say T1 also, T2 also has a, let's say, locking phase, and then followed by some time you have a unlocking phase. So if this is the case, how does it guarantee conflict serializability? Is once you have gained the lock over here, right, and over here too, right, let's say first of all these two locks cannot be gained simultaneously. We know that let's say here T1 is asking lock on A and it has gained lock on A, then at that time T2 cannot gain a lock on A, it has to wait. So maybe later in time at some point over here it will gain lock on A when it has released, right? So first it has to release, T1 has to release the lock, and then only T2 can gain the lock. So once I have started locking, right, and sorry, not started, once I have started unlocking, I will not again ask for a lock. So if I do not ask for a lock again, I will not have a dependency in this direction. Try to understand it intuitively. So once I have the locks of T1 at first, right, so I might have a data item dependency on T2 in this direction, right? Why? Again, I'm just let's explain it in this way. Uh, so T1 has gained lock on, let's say, a variable. It is done over here at some point, right? And then T2 is asking for lock on A, but T2 cannot get lock on A unless you do the first unlock over here. A is being unlocked. So T2 is basically waiting in all this area. It is not doing anything. So after that, some point of time here, when the unlock is done, then T2 is basically gaining the lock on A. So here it is gaining the lock on A. So I have a dependency in this direction, right? But if there is a possibility, let's suppose if there is a possibility, if I somehow allow A to be locked again later in some point of time by T1, right? So once the unlock phase has started, later again I allow the lock on A to be gained by T1 again. So let's say I allow lock A, which is being prohibited by two-phase locking, but let's say I allow it. So then again, this lock A will be dependent on the T2's release of lock, because T2 has already gained the lock on A, so it will depend on release of lock. So unless and until T2 is doing that, T1 cannot proceed. So there will be a cyclic dependency like this. Okay. And that's why we might run into conflict. You see, from conflict serializability, when did we say that it is not conflict serializable? When cycles were getting formed, right? So if T1 and T2 is there and there is a conflicting pair from here to here, let's say write A and read A, right? And then again at some point of time later, over at after some instructions, right? Some instructions are here. Then at some point of time again, here I have read A or write A, whatever. Write A doesn't matter. And then again here I have one write A, right? So then I have a dependency in this cyclic order, or dependency over here in cyclic order. So this is creating this cycle, right? So T1 to T2 and then again T2 to T1. So because of this, conflict serializability was not guaranteed because of the formation of cycle. So this is what it is here also. If I allow locks to be gained again after doing unlock once, then there is a possibility of formation of these cycles, and that's why these counter dependencies will happen, and I might run into deadlock, and I might also run into these conflicting instructions, and that's why it will not be a conflict serializable. So that's how the basic intuition of two-phase locking is, that once I start unlocking, I will not allow any more locks to be gained on the data items in a particular transaction. Fine. So that's a kind of recap on two-phase locking. But now we will see some properties on two-phase locking. See, two-phase locking creates conflict serial schedules. So we have understood that. And the order of serializability will be the order of reaching the lock point. So this is what it means is, once we put the locks according to the two-phase locking rule within the transactions, right? The order of we know that after doing two-phase locking, we will get a conflict serial schedule. But once we get the conflict serial schedule, how can we say what is the serial order, right? By precedence graph, we used to check the serial order. But here, how can we understand it? It is based upon the lock point. So lock point means this point, first unlock. So in this transaction T1, this is our lock point. We will have an unlocking phase followed by a first unlock and then the unlocking phase. This first unlock is basically called the lock point. So whichever transaction in a schedule, so let's say a schedule has 3 transactions, whichever transaction in the schedule is reaching the lock point at first, that will be in the first position of the serial order. And then let's say another T2 transaction or some other transaction is the one which is reaching the lock point after the first transaction, then that will be the second in the serial order, and accordingly we will go. Right. So whichever transaction is reaching its lock point at first, that will be the first in serial order, and this is how we will derive the serial order. Okay. But two-phase locking, this is the lock point. Let me mention. Okay. But two-phase locking does not restrict the occurrence of dirty read, and hence it does not guarantee recoverability. So this is something different, that in two-phase locking we have not talked about commit, right? So when are we committing, when are we releasing? So that we have not, that two-phase locking protocol does not talk or does not put any constraints on that. And since it does not put any constraint on committing of the transaction, and that's why dirty reads can happen. Now, since I'm not committing, and once I unlock, so basically what I mean is, so let's say I have a transaction T1 and T2, and let's say I used a lock on A, and then I am, let's say, writing exclusive lock on A, and then I'm writing A. Okay. And then I am doing unlock on A. So once I am doing unlock on A, that means I can I cannot ask for any more locks on A or on any other data in T1. So please be aware of this. When I say that I am unlocking A, that means not only I cannot ask for lock on A further in T1, I cannot ask for lock on even any other data items as well. Okay. So that is something you must understand. Okay. So we have done unlock on A over here. Now once unlock on A is done, then since exclusive lock, not even exclusive lock, let's say I put a shared lock since I'm only reading. So I will put a shared lock, okay, on A, and then let's say I read the value of A, okay. And then let's consider that some problem happened over here. Uh, okay, so before that problem, let's say I commit. I have read the value of A and that's it. I don't have anything else to do. I commit the transaction. But let's say over here there is some issue. Okay, some abort, right? So basically it will roll back. Some error happened. System crashed or some crash is happening. Maybe system crash, maybe some functional problem, whatever, maybe due to some malfunction, the T1 transaction is aborting at this point, right? And but before that, commit has already been done by T2, and T2 has read the value of A which was being written by T1. So T2 is reading the value of A which was being written by T1 and committing it, but here T1 is getting aborted later in time, and that's why it is going for a rollback, right? It will roll back. Now, according to the concepts of atomicity of transaction, since this T1 is not completely executed, all the changes related to T1 must be rolled back. So this write is invalid. But this write is already read by T2 and it has already committed it in the database. So this is something which is irrecoverable. This is not a consistent position, since this RA should not have read the value written by T1 because T1 has already rolled back. So that's why, but I cannot do it because it has committed. So this is an inconsistent state. And what we call this inconsistent state is irrecoverable schedule. I cannot recover this schedule to the previous state because it has committed. So basically, since I have followed two-phase locking also, according to the two-phase locking rule only I have followed, but still I cannot prevent dirty reads. And because of these dirty reads, I can also run into irrecoverability. So this is what this statement is saying. Another big disadvantage is it is prone to deadlock. Now, any locking principle, like the two-phase locking principle, there is a chance of deadlock, and most locking will get into deadlock. And to prevent deadlock, we follow other protocols like timestamp ordering protocol or some other protocols, right? So deadlock is another issue. So these are the concepts of related to two-phase locking. But rigorous two-phase locking guarantees cascadeless recoverable, because rigorous two-phase locking basically what it does is it simply says that you commit before you unlock. So before T1 is unlocking, it will say directly commit. Write whatever you want to do and then commit. So according to the rigorous two-phase locking protocol, you simply don't unlock it like this, you simply commit it at first. So you commit. Now, if just even without unlocking I am committing something, then that means any other transaction will not get a chance to put a lock on that variable, right? Because I have not yet unlocked. So it will implicitly guarantee recoverable and cascadeless recoverable schedule. So that's what rigorous two-phase locking is saying. Only difference within rigorous two-phase locking and two-phase locking is rigorous two-phase locking does not unlock, it directly commits after whatever changes it needs to make. Okay, fine. So then I have strict two-phase locking is a better choice performance-wise than rigorous locking along with all the benefits. Okay, so this is strict two-phase locking is a little bit more improvement on the rigorous two-phase locking. What rigorous two-phase locking is saying is, okay, that what I'm trying to, in rigorous two-phase locking, I will directly commit without even unlocking. That's what it is doing. What is strict two-phase locking saying? That okay, you hold the locks and do whatever you need to do, then you simply, I mean, commit, and that is also fine. But what is the problem with shared lock? Only exclusive lock is the thing where we have to be careful. Why? See, what is happening in this example? In this example, there was a dirty read happening earlier, right? This RA was a dirty read because T1 was writing A and then later at some point here it was aborting, right? And before that aborting, and before that this commit was happening in case of T2. So all of this is happening because T1 was writing something which T2 was reading and then T1 was rolled back. Okay. So the problem is with writing, not with reading. Dirty reads will happen when there is a writer, okay, not if both of them are reading. So strict two-phase locking is saying that why are you putting the constraint of on reading as well? So you take the locks as required, do the commit without unlocking, and that will prevent irrecoverability according to the rigorous two-phase locking rule, but at least allow the shared lock to be released, right? You can hold on to the exclusive lock until the commit, but do not need to hold the shared lock until the commit. So at least allow the shared lock to be released before the commit in T1, so that anyone who is trying to read T2, anyone who is trying to read a variable, any transaction who is trying to read a variable which has not been written by T1, right? Because a shared lock means what? It has not, if I try to take a shared lock on a variable, then that means that variable is not being written by someone else. Otherwise, that variable would have an exclusive lock and I will not get the shared lock anyway. Right. So all the data items, strict two-phase locking is saying all the data items where T1 has only uh, put shared lock, right? Release those shared lock. Where T1 has put exclusive lock, hold them till commit, and you commit without unlocking, like in rigorous locking, but just leave the, unlock the shared lock at least. Okay. So strict two-phase locking says for the shared lock, do unlock. For the exclusive lock, do not unlock until commit. This is the difference between strict two-phase locking and rigorous two-phase locking. Rigorous two-phase locking says whatever it is, shared lock or exclusive lock, whatever it is, once you get the lock, do not unlock it, directly commit. Fine. And strict two-phase locking, obviously it guarantees, just like rigorous two-phase locking was guaranteeing recoverability and conflict serializability, strict two-phase locking also guarantees recoverability and conflict serializability. Only thing is that strict two-phase locking actually is a better performance-wise because we are releasing the shared lock, and that's why some operations of other transaction can proceed accordingly. So that is only the benefit of here. Performance-wise, it is a better option. I discuss these topics related to locking because we do not have any other questions in, at least in PQ, where we can discuss these concepts, but these will be needed, might be needed in your graded question or even in your other end-term questions. But this rigorous and strict two-phase locking was not directly required for solving this question. So let's come back to the question, and we have discussed all the types of two-phase locking rules, and now we will solve it, how solve this question. So conflict serializability part was done. Now the other thing is all conflict serializable schedules are two-phase lockable. We will think about this statement a little bit later. What it is asking is all conflict serializable schedules are two-phase lockable. Please keep in mind what we saw in this statement. It is asking two-phase locking creates conflict serial schedules. That is, two-phase locking guarantees conflict serializability. And what is my statement saying? It is saying conflict serializable schedules are two-phase lockable. These two statements although sound similar, but they are different. This is saying that if I have a conflict serializable schedule, right, this statement is saying if I have a conflict serializable schedule, then it must be two-phase lockable. And what we have learned earlier, if I apply two-phase locking on a schedule, then it will become conflict serial schedule. These two are different thing, right? So whether this statement is true or not, we will check a little later. All conflict serializable schedules are two-phase lockable. That I don't know. All I know is all two-phase lockable schedule. At first you apply locking, and if it is possible that you are able to apply two-phase locking on that schedule, then it will be conflict serializable. Okay. So we will worry about this statement a little later. At first, let us try to solve this statement. The given schedule is two-phase lockable. So let us apply two-phase locking on the given schedule and see whether it is so or not. Okay. So fine. So what does two-phase locking states? Two-phase locking states that I will try to put exclusive lock on any item which is being written. I will try to put shared lock on any item which only I need to read. And once I start unlocking even one data item, I will not be able to gain lock on any other data item. So these are all the rules. Now we will start writing it. So there I have a WP, which is the first instruction in the timeline. So writing P, right? So in order to write P, I must have a lock on P, right? Exclusive lock. So exclusive lock, I am writing X lock, okay? Exclusive lock on P. So once I have an exclusive lock, then I can write. So then what I do is, can I write unlock over here? Unlock P. See, the thing is, once I do unlock P, I will not be able to put a lock on Q. And later in the transaction, I need to put a lock on Q so that I can write on Q. Okay, so I cannot do that. And that's why I will not unlock P now. We will have to think about something else. So what we will do? If I do not unlock P, if I just keep it as it is and I proceed further. So in T1, I have again writing on P, right? So if I have to write P variable in T1, I again need to put an exclusive lock, but that I cannot do because exclusive lock is already gained on P by T2 transaction. If I cannot even do unlock because then I cannot gain the lock on Q. So this is the trouble. So what I do is I would let's put a lock on Q as well. Okay. So what I do is here only I put a exclusive lock on Q, right? And then I unlock P. This is okay, right? So I put an exclusive lock on Q and then I unlock P because I know Q is the only data item. There are no other operations after this, right? So Q is the only data item where we have to write. And I have already achieved the exclusive lock on Q and then I have unlocked. Okay. I need to worry that because once I unlock, I cannot gain the lock again. So this is what I do. Okay. Then there is write P. Since I have unlocked P, now I can gain the lock. So this is going exclusive lock. This is doing exclusive lock on P. Now once I have gained the exclusive lock on P, I will write P. Okay. So then again write P is here in T3. Similar problem. If I write unlock in case of here, unlock P over here, then again I cannot do the write for this particular Q variable. Right? Now can I write exclusive lock Q over here? No, because an exclusive lock of Q is already being, T2 has already taken that, right? So now what can I do? I mean, there is no other option, and that's why we are at a stalemate. We cannot go further. But let us, even here only you understand that there is no other option to go ahead. If I want to execute this statement, then there is no other way. But let us forget this statement just for the confirmation. Let's just still proceed and see what happens at the end. Forget about this statement now and see what happens now. If I, let's say, unlock P, in at least because I do not want to see what's happening later in time. I just want to do this at first because this is the next thing. So next instruction. So I simply unlock P. So once I do unlock, then again here I can get the exclusive lock on P and then I can do the write. Okay. Then I can also unlock because there are no other operations for T3 transaction. So simply let's say unlock P. Now WQ is here I have reached. We have already taken the exclusive lock on Q, so I do not need to worry about anything else. I can directly do WQ, write Q, and then I can unlock, unlock Q, right? So till now this was all fine, but now when I come back to T1, right? When I come back to T1, I see that in order to write Q, we need to get exclusive lock on Q. and we have already started unlocking here, so that we could have written this WP by gaining the lock on P in T3. That's why we needed to unlock P in T1 over here. But here again we cannot write exclusive lock right on Q now. The reason is we have started unlocking, and according to two-phase locking protocol we cannot do that. Yeah. So this is the trouble, about it, and that's why this is not possible. We cannot do the locking according to the two-phase locking protocol of this schedule. So you see that since this schedule is not two-phase lockable, so we have concluded the given schedule is two-phase lockable. False. This is not two-phase lockable. So now you see that this this schedule was already a conflict serializable schedule, and that we have seen the order is 2, 1, 3, but the same schedule is not two-phase lockable, right? The given schedule is two-phase lockable, it is false, it is not two-phase lockable. So from these two you can understand that all conflict serializable schedules are two-phase lockable is also a false statement, right? So this is something very beautiful. As you can see that all conflict serializable schedules are not two-phase lockable, but if you can apply two-phase locking on a schedule, then it is guaranteed to be conflict serializable, right? So that's the whole concept of this practice question number 7. And thank you everyone.